Hello, welcome back to my channel. My name is Gina. In this video, we're going to prove the sum and difference rules in calculus. So the sum and difference rules states that if a function equals to f of x plus or minus g of x, then its derivative equals to the derivative of f of x plus or minus the derivative of g of x. So to prove this, we'll start with the definition of derivative function. So assume the function is f of x plus g of x, then its derivative would be limit of f of x plus h minus f of x, which is the difference in y, over the change in x, h, as h approaches 0. So now let's substitute the function into this limit. So this equals to limit as h approaches 0. F of x plus h equals to f of x plus h plus g of x plus h minus f of x plus g of x over h. Now let's group the first and the third term together, and the second and the fourth term together. So this equals to limit as h approaches 0 of f of x plus h minus f of x over h plus g of x plus h minus g of x over h. And recall that the limit is distributive. So for example, limit of a plus b equals to limit of a plus limit of b. So here we can distribute the limit to the first and the second term. So this equals to limit as h approaches 0 of f of x plus h minus f of x over h plus limit as h approaches 0 of g of x plus h minus g of x over h. And by the definition, the first term here equals to the derivative function of f of x. And the second term here, by the definition of derivative function, this equals to the derivative of g of x. So this equals to derivative of f of x plus derivative of g of x. So now we just prove the sum rule. Similarly, we can prove the difference rule, but instead of f of x plus g of x, we use the minus sign. And with the same approach, we can prove the difference rule. Now let's look at some examples. In the last video, when I talk about calculus, we've proven the power rule, and I'll put the link up there if you need to review the video. So the power rule states that if a function equals to x to the power of r, where r is any real fixed number, then its derivative is r times x to the power of r minus 1. So now let's look at the example. For f of x equals to x cubed plus 2 times x squared plus 4. So here we have a function of x plus a function of x plus another function of x. So its derivative equals to the derivative of the first function plus the derivative of the second function plus the derivative of the third function. So this equals to 3x squared for the first term plus, so here we have a constant in front of x squared. And at the end of the last video, I've briefly mentioned the constant multiple rule, which states that if a function consists of a constant times a function of x, then its derivative would be the constant times the derivative of the function. So here this equals to 2 times the derivative of x squared, which equals to 2x, plus derivative of 4. And derivative of a constant equals to 0, and that is called the constant function rule. so the third term equals to 0. So the derivative of f of x is 3x squared plus 4x. Now let's look at the second example. F of x equals to 4 times square root of x minus cube root of x. So here we have a function of x minus a function of x. So according to the difference rule, derivative of f of x will equals to derivative of the first function minus the derivative of the second function. And now we can use the power rule. So this equals to, here we want to rewrite the functions in the form of x to the power of r. So the first function is 4 times x to the power of half minus the second function is x to the power of a third. So now let's use the power rule. So this equals to 4, the constant, times r for the first function is 1 over 2. So this equals to 1 over 2 times x to the power of 1 over 2 minus 1, which equals to negative 1 over 2. Minus the r for the second function is 1 over 3. So its derivative is 1 over 3 times x to the power of 1 over 3 minus 1, which equals to negative 2 over 3. So this equals to 2 over square root of x minus 1 over 3 times cube root of x squared. So that's the end of the video. If you have any questions, feel free to comment below. And I'll see you in the next video.